Okay, here we go with part 2. All right, we're on question 10. All right, g of f of x. So that means I'm going to lead with the g function. So I'm going to lead with this. I'm going to put in f. Okay, so what that means for me, squared means this. So I'm going to go ahead and create my little boxes here. All right, 2x plus 3, 2x plus 3. All right, 2x times 2x is 4x squared. Okay. All right, that's going to be 6x and 6x. All right, 3 times 3 is 9. Okay. So when I combine my like terms, I got 4x squared. Okay. 6 plus 6 is 12. I've got positive 9, and since I have positive 9 and negative 2, that's going to turn into positive 7. Okay. If f of x equals that, what could f of x and g of x be? Pretty simple. We sort of work backwards here. Where there's a parentheses, take that out and put x. So f of x would be this. Ask yourself, what did I put in parentheses? I put in x plus 3. Okay? So the x plus 3 part ends up being your second function. Okay? To get what this is, just move out those parentheses. All right? And you should be able to get that pretty easy. Okay, what is the domain of the following? So what I got to look at is, here's my anchor point. It goes all to the right. That coordinate right there is going to be negative 2, 1, 2, 3, and 4. So negative 2, 4. So if I look to the right, I see the graph. Left, no. It's going to be greater than negative 2. Whoops, let me back that up real quick. That's not the right answer. It's going to be x is greater than or equal to negative 2 because it's a filled-in circle. Okay? Number 13, what is the range of the following graph? All right? Okay, so I got 1, 2, 3, 1, 2, 3, 4, 5, and 6. So that's 3, 6. Okay, since I'm doing range, I look below all my graph is. Okay, so what I got is all real numbers such that y is less than or equal to 6 because everything is below. All right, 14, what are the x-intercepts of the graph? All right, 0, 1 is an intercept, and 1, 2, 3, 4. So these are the intercepts. All right, so that's 4, 0. Okay, pretty simple there. Pretty simple stuff. All right, moving on to 15. What are the x-intercepts? Now, this is the x-intercept line. Doesn't cross, so there are none. Okay, moving right along, 16. Okay, when we do intervals where it's increasing and decreasing, I got to label these coordinates. That's going to be negative 2, 0. That is going to be let's just estimate that at 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 2, negative 10. And let's estimate this. Actually, I don't have to estimate that because that's an arrow. All right, so what I got here, this is negative infinity. This is positive infinity. All right, so if I'm doing increasing, decreasing, all right, I trace my finger. So there's the increase, decrease, increase. So from negative infinity to negative 2, I'm increasing. Okay? From negative 2 to 2, I'm decreasing. Okay? And then from 2 to infinity, I'm also increasing. Okay? All right, so that's pretty simple. Only the x values count. We're not worried about the other ones. Okay? Draw an example of each type of function. A linear would be a line. So we'll label that A. An absolute value is a V. We'll label that B. A square root is a point with something like that. And a quadratic is a U shape. Okay. 2. Just make sure it has a U shape to it. Okay, pretty simple there. That's almost a recall type question. All right, moving on to the next. Which describes the best translation? Okay, well, what's happening with my anchor point? Well, my anchor point is negative 5, negative 4. Well, what's happening there? Well, that's left and that's down. Okay, so that's going to be up 4. No, that's not it. Down 4, left 5. Yep, there you go. Okay, all right. Rewrite the log form of the equation. All right. Well, I know my log is going to have the same base. Okay. There's 2 parts left, 2 and 64. In the conversion, it can no longer equal the same thing. So the 2 goes there, 64 goes there. Converting to the exponential, my base is 5. It can no longer equal 2. It's got to equal 25. that's going to be 5 squared. Okay, so there's 3 parts to this. Set the base, okay, that's the first thing, and then it can't equal the second thing. Can't equal the same thing. Okay, that should help you, all right, figure it out. Can't equal 64, there's only 2 in 64, so 2's got to be the answer. Okay, finding the inverse, okay, so I'm going to switch x and y here. I'm going to move this over. Okay, so what I got here is I got x minus 5 equals 7y. Now it's time to convert, now that that's been isolated. So as a log, okay, all right, as a log, the base is going to be 7. It's no longer going to equal this, it's got to equal that. And the x minus 5 goes right there, and that's going to be your answer. All right, describe the transformation of this graph. What other transformation applies to the graph? Find the inverse equation. Okay, this is a base 10 if you don't see it, okay? All right, so what's happening here is this anchor point's going to be -2, -1, so that's left 2, down 1. Okay, I think it froze a little bit. That's going to be left 2 and down 1. All right, hopefully my board comes back here. Okay, all right, there we go. Left 2, down 1, okay? All right, so that's the transformation that it's applying, okay? Find the inverse equation, all right? Very similar to what we just did before, all right? I'm going to move that 1 over, okay? I'm going to have that as x, okay, because I switch x and y. I'm just sort of skipping a little bit of a step there, all right? Hopefully, all right, so all I did was switch x and y. I moved that 1 over, okay? That's isolated. It can I'm going to set the base, it's 10, can no longer equal that, it has to equal y plus 2, the x plus 1 goes up top there, all right, and to finish the problem out, I'm going to subtract 2, so what I have here is this for an inverse, all right, that is your inverse function, okay. Let me check the time here. Okay, great, I got plenty of time to finish this. 15, 16, 17. All right, basically we're on the last question. All right, this is pretty good. Moved along pretty quickly here. Okay, write the equation of each of the following graphs. Okay, so what I got here is I got -2, 2. Okay, so from an absolute value standpoint, that's an absolute value of x plus 2 and plus 2, opposite on the inside. Now, what I have to do is, what are my normal points? My normal points are 1, 1, 2, 2, 2. So I look at where am I? 1 over, okay, I go down to here, so that's 1 over, 1, 2, 3, like 1, 2, 3, okay? And then to get to 2, 1, 2, 1, 1, 2, 3, 4, 5, and 6, okay? So that's 2, -6. Well, how would you go from here to here? A multiplication factor of -3. So I got to put -3 in there, that's the absolute value. Okay? This is a square root, okay? So f of x equals the square root, all right? My anchor point there is -1, 2. So I'm going to be x plus 1 there, plus 2 on the outside, all right? And I'm going to look at where my points are, all right? That's 1 over 1 up, 1, 2, 3, 4, 1, 2, okay? 4 over 2 up. So normally I'm 1, 1, I'm still 1, 1. I'm 4, 2 normally, I'm still 4, 2. So nothing's going to happen there. That's going to be my answer. Okay, so I end up having the same exact points that I normally have. All right, this is a quadratic. So I look at that, that's 1, 2, 3, 1, 2, 3, 4, 5, and 6. Okay, so as a quadratic, I'm going to have the squared with x minus 3 and the plus 6 on the outside. Okay. My normal points for the quadratic are 1, 1, 2, 4. If I go 1 over, I'm 1 down. I'm 2 over, I'm 1, 2, 3, 4 down. Well, how you get from there to there? Okay, same one. You multiply by -1. So I'll put a -1 out there, and that is my answer. Okay? All right? Don't forget the squared in there. All right? So as you're going through this, all right, what you want to do, a lot of things are very common on graphing, anchor points. Inside the function, you want to go opposite of x. Outside, you follow. That's common. Know your key points. Okay? So know your key points. What are some of your key points? For quadratic, 1, 1, 2, 4. for absolute value of x, you're 1, 1, 2, 2. For square root, okay, you're 1, 1, 4, 2. Okay, all right. Understanding those anchor points is going to be key. On absolute value, use your calculator as much as you can. That can help you as well. Okay, all right. And as a review, how do you get to absolute value? You go to option, all right. And let me go back into the graph menu, graph. Okay, you go to option num ABS. Okay, that can help. Anything that you graph, all right. Anything that you graph, G-solve, that kind of thing helps. Roots are where it crosses there. All right, minimums can also be that. All right, intersections are where these things meet. Okay, all right, and if you go over that review, you should be fine for the test.